Hi class, welcome to the Physical Behavior of Matter review. In this next test, we're going to look at the physical behavior of matter. We're going to focus on the three principal phases of matter: solids, liquids, gases, and solutions, mixtures. For solids, we're going to be concerned with the basic characteristics of solids and how bond type influences the characteristics of solids. For liquids, we're going to focus on the basic characteristics of liquids and how vapor pressure and intermolecular forces play a role in the properties of liquids. For gases, we're going to look at real versus ideal gases as described by the kinetic molecular theory. From there, we're going to apply the principles of the combined gas law. And also look at the relationship of the number of particles of gas under specific conditions. Now, for solutions, we're going to look at what is a solution, going to concern ourselves with solubility as described with reference table F. We're also going to look at solubility in terms of concentration on reference table G, looking at saturated, unsaturated, and supersaturated. Solution will also look at trends of solubility of solids and gases in aqueous solutions. Solubility will also look at calculating concentration, and concentration is calculated in molarity, parts per million, and percent composition. Finally, in solutions, we'll look at why certain substances dissolve and basically explore the like dissolves like concept. Some of the ideas on the physical behavior of matter review sheet are very important in discussing the physical behavior of matter, but they've been tested in earlier portions of the course, and so that we can test your true understanding of the most recent content may not be tested on your upcoming exam. A fantastic place for review will be your High Marks book. I recommend you examine High Marks Chapter 1B and High Marks Chapter 6. I will post an image of the multiple choice answers in the next slide. There are some important things to note here on reference table H. Table H gives the vapor pressure of 4 different liquids. You can notice that as the temperature increases, the vapor pressure of the liquid increases. So we know that as temperature increases, liquids tend to evaporate more quickly. Also recall that the normal boiling point correlates with the intersection of any given line with the vapor pressure of normal or standard pressure, which is 101.3 kilopascals. So for propanone, the normal boiling point occurs here at this intersection. So you will have to just read the graph down to see what the normal boiling point is. Please also note that on the x-axis, the scale is by 5s, but on the y-axis, the scale is by 10s. So the normal boiling point of propanone is approximately 55 degrees Celsius. The last big idea to look here is that when liquids evaporate very easily, they are not held together by strong intermolecular forces. Or liquids that do not easily evaporate, they are held together by strong intermolecular forces. Therefore, the stronger the intermolecular force, the lower the vapor pressure. This means the more intermolecular forces a substance has, the more it will resist evaporating. Now let's begin with our standard review sheet. Recall that standard review sheets have major understandings in bold and practice questions below. Now, many of the concepts in this unit of physical behavior and matter have been discussed in previous units throughout this school year. Because have already tested some of these concepts due to a lack of time and length restrictions for our test, some of this material will not be focused on. However, all of this material should be readily understood by you and could appear on a test. I will highlight the questions that most closely align to our focus, which is the composition of matter, solids, liquids, and gases. In the first question, we were asked which substance, now the word substance refers to either an element or a compound, can be decomposed by a chemical change. So decomposed means broken down, and by a chemical change, so this means that I could break bonds. Substances that are held together with bonds are called compounds. Pure substances that are not held together by bonds, because they only have one kind of atom, are called elements. All the elements are listed on reference table S. Let's take a look. So while examining reference table S, we can see that we can find the element calcium, number 20. We also can find the element copper, number 29. And we can also find the element potassium, number 19. The element that is not listed, or the substance that is not listed, is ammonia, because ammonia is not an element, it is a compound. So it can be broken down by a chemical means. The next question is a question that could very likely appear on your test. It's given a particle diagram, and it says at 101.3 kilopascals, which table A tells us is standard pressure, and 298 Kelvin, which is 25 degrees Celsius, roughly room temperature, which element could be represented in this diagram? So when we look at the particle arrangement of this diagram, the particles are arranged very neatly and very close together. This diagram best represents a solid. So the question is which element is a solid at 298 degrees Kelvin? Recall, to find the state of matter, we can use reference table S and create a number line. Recall, to figure out the state of matter at a given temperature, you create a number line using the given melting point and boiling point. And what you'll do with this number line is you'll figure out where your number of interest lies. If your number of interest lies before the melting point and boiling point, or to the left, you'll have a solid. If the number of interest lies between the melting point and boiling point, then you'll have a liquid. And if it lies after the melting point and boiling point, then you'll have a gas. Let's look at an example from the question. So let's use an example from the question with krypton, element number 36. Krypton has a melting point of 116 Kelvin and a boiling point of 120. So if we made a number line with those values, so here we have a number line with these values. We have to insert the temperature of interest from the question, which is 298 Kelvin, into this number line. The value 298 falls to the right, or here in the number line. That means that krypton is a gas at room temperature. So what you'll have to do is imagine look up the data from reference table S for the other elements. So we have silver element 47, xenon element 54, and radon element number 86. Notice I've just rewritten the melting point and boiling point data for these elements here. And now I need to take the number of interest. The number of interest from the question was 298 Kelvin, and place this on the number line. Now 298 will fall here on silver's number line. This makes silver a solid at room temperature. In xenon, the number 298 falls here, making it a gas. And radon, the number 298 falls here, again making it a gas. Now since we are looking for a solid, silver is our best answer. So based on the state of matter, we know that silver is our best choice. Now, these next questions should be reviewed from earlier in the year. They are not likely going to be on our exam. Question number 3 asks, which is a pure substance? Now, if it has one pure substance, that means it has one particle type. So to find a particle type, just take your pen and circle the pieces. You can see here that in choice 1, there's only one particle type. In choice 2, we have this particle type, the diatomic element, and this particle type. There are two different particle types. We'll also have two particle types in choice 3 and two particle types in choice 4. Question 4 asks us to identify a pure substance, and pure substances have only one particle type. So the substances that have only one type of particle have to either be individual particles or they have to be particles that have bonded together in the same way. So that means that pure substances only include elements and compounds. In question number 5, we're looking for a compound. Now, compounds have a chemical bond. And we're looking for a compound in the gaseous phase. And the compound that has only one compound would be 3. So we see the bonds between the open and closed circles, and we notice that this is one pure compound because each of these particles are identical. Now, in question 2 or choice 2, these particles are different. And since they are different, it is not pure. And in question 4, it has chemically bonded particles, but again, these particles are different. The next part of our review sheet focuses on solutions. Solutions will be found in Highmarks Chapter 6. At the conclusion of the solutions review, I will post the Highmarks Chapter 6 multiple choice answers. The first question we have about solution describes dissolving, completely dissolving. Anytime we see the keywords completely dissolving, we've made a solution. Now, the word solution is synonymous with a homogeneous mixture. Now, the next question asks about solubility. And it asks about the solubility of potassium chlorate. Solubility can be found on reference table G. To examine the solubility of potassium chloride on reference table G, we'll find its line of interest. And we'll see that as temperature increases, the solubility also increases. This is generally true for all solids. As temperature increases, solubility increases. Recall that for solids, as temperature increases, solubility of solids generally increases. Pressure does not affect the solubility of solids, though it does increase the solubility of gases. In question number 8, we're looking for the substance that is most soluble in water. Recall, when dissolving substances in water, we're going to recall a rule, like dissolves like. This means that polar substances like water will dissolve other polar substances. It also means nonpolar substances will dissolve other nonpolar substances. Water is polar because it's asymmetrical. So here we're looking for another polar or asymmetrical molecule. This ties together many big ideas from our bonding unit. It is important that we review and we remember all the information we amass throughout the year in chemistry. So polar molecules are considered polar because they have asymmetrical on both the horizontal and vertical axes. Now, a shortcut to remembering polarity is that polar substances tend to have an odd-numbered final subscript. So here, when we look at the subscripts, carbon tetrachloride has a final subscript of 4, which is even, making it nonpolar. Hydrochloric acid has a final subscript of 1, because 1 is understood, making it odd. So it is indeed polar. Carbon dioxide has a final subscript of 2, as does nitrogen. So we pick the final subscript is odd and hydrochloric acid. Questions 9 and 10 look at something called colligative properties. These are properties of pure solutions or pure solvents that change when you add a non-volatile solute. The more non-volatile solute that is added to a pure solvent, the more drastic the effects of lowering the freezing point and raising the boiling point will occur. Now, I like to remember this in terms of an alligator's mouth. So if you have an alligator sitting around and he would like to consume a few particles, he's going to have to open his mouth a little bit. And to open his mouth, he's going to increase the top, raise the boiling point, and he's going to decrease the bottom, lower the freezing point. Now, if you add more particles, then the effect is going to be more pronounced. So the bottom jaw will have to decrease even more, and the top jaw will have to increase even more. So it's always that the boiling point goes up and the freezing point goes down. So here we look compared to a 0.1 molar, a 0.8 molar solution should always have, since it has a higher molarity, it should have a higher boiling point and a lower freezing point. Now, in question number 10, we are looking for what affects the solubility would be most affected by pressure. Now, pressure pretty much only affects gases. So basically here we're looking for which substance is a gas. And you should know that carbon dioxide is a gas at room temperature. So a quick little summary of colligative properties before we move on. Colligative properties do not matter the substance that is added to a pure solvent, but instead what matters is the number of particles. The number of particles is determined first by molarity. Higher molarity always has higher effect. The second thing that determines the number of particles is the type of bonds. Ionic bonds always produce more particles than covalent bonds. And ionic bonds produce the total number of particles based on the number of ions present in the formula. For binary compounds, this can be seen by the total of the subscripts. For compounds that contain polyatomic ions, you'll have to use some more inspection and look at Table E to determine exactly the number of ions found in a substance. So here you'll see that when having an ionic compound, recall that ionic is metal or nonmetal, to find the total number of ions, if it's binary, meaning there's 2 capital letters, you simply have to add the subscripts. So here, the subscripts 1 and 1 add up to 2. Or for magnesium chloride, again it's binary because there are only 2 capital letters, the subscripts add up to 3. But if there are more than 2 capital letters, then you must have a polyatomic ion. And polyatomic ions are found on reference table E. So sodium nitrate has only 2 ions versus barium hydroxide has 1 barium and 2 hydroxide ions. Multiple polyatomic ions are easy to recognize because the formulas are written with parentheses.